What's up everyone, I'm Dev. In this video I'm going to teach you how to use pgvector's Docker image as a vector database in the LangChain project. Before starting the video, as a prerequisite, you should know Python, LangChain and the concept of vector database. Perfect. Now let's start the tutorial. I will be doing everything step by step so it's easy for you to follow along. Firstly, create a virtual environment for Python. Perfect. Now I will activate the virtual environment. There you go. Next, I'll create a file dockercompose.yml to list the pgvector image. You can also pull and run the image from terminal, but I like to use dockercompose.yml because it becomes easy to list all the requirements and then run the container using just one command. Here is the content of dockercompose.yml file. For this tutorial, we'll only use one service, hence I'll list pgvector/pgvector:pgvector16 image. I'm passing all the required environment variables from pgvector.env environment file. Further, I am using the same port to access the database. Lastly, it requires a volume to store the data. You can name this anything. Finally, list all the volumes. As a next step, we need to create pgvector.env file to list down all the required environment variables. These are the three environment variables required to set up the pgvector image. You can give this variables any value. I usually add the name of the project. However, once you give this value and the volume is created, you'll only be able to access the database using these values unless you delete the volume and recreate it. Now I will create a db.py file which will have a function to get the pgvectors instance. In this file, I'll create a function getVectorStore. In this function, firstly, we will take the values of all the required environment variables. In the next step, we will declare an embedding model. I'm using Gemini's embedding model, but you can use anyone you want. Lastly, we will initiate the pgvector by using the required parameters and return it. Before writing the logic of the function, we need to create a new .env file which will store all the environment variables required for the project. In this file, we will declare these environment variables. Again, you can name the collection anything. For the connection string here, you need to manually paste the values of the variables declared in pgvector.env. The value of the user should be here, the password should be here, then the URL where the database is serving. For now, since we exposed port 5432 from dockercompose.yml, it can be accessed at localhost 5432. Lastly, the name of the database. All of these values are the values of these environment variables. Coming back to db.py, now we can import all these environment variables. To do this, first we need to download .env using pip install. The next step is to get all the required environment variables. Hence, import load.env from .env and import os. Then load the variables using load.env function. Now getting the value of these variables. So these are all the environment variables we would require. The second step is to initiate the embedding model by passing the API keys. For using Gemini's embedding model, I need to install LangChain Google GenAI. Once this is installed, we can import this. We also need to install LangChain Postgres. Perfect. The last thing for this function is to declare pgvector instance and return it. The instance of the embedding model, connection name and connection string is passed to declare the instance of a pgvector. Finally, return this instance. We also need to install a few more dependencies. Great, this function is now complete. Now for the main purpose, I'll create app.py. This will first load the data from a document and store it in a pgvector. Further, when user passes a prompt, it will retrieve the relevant chunk of data and pass it to the LLM to generate the response. Perfect. Here are all the functions required for the operation, which I will discuss. Firstly, getDocumentContent will return the content of the document. Store data will accept the data, split into chunks, and store it in a vector database. GetRelevantData accepts the user's query, calls the vector database to get the relevant chunk of data. Lastly, PromptLLM will accept the user's query and the relevant data to pass it to LLM and generate the response. Lastly, in the main function, I will call all the functions declared. Before moving further, we need a PDF document to use as data. For this purpose, I'll use my resumes PDF. Now I will first complete getDocumentContent function. There you go. So in short, this function will load the PDF, read its content, and return it. The second function is to store data. This is one of the main part of the tutorial. To store the data, firstly, we need to convert it from a string to document type. Hence, firstly, we need to install LangChain using pip install LangChain. Great. Now let's import it. Now, perfect. So this would convert the data from string type to document type. In the next step, we need to split this document into several chunks. Hence, we need a text splitter. Therefore, we need to install LangChain text splitters and import recursive character text splitter. Now we need to initiate an instance of this text splitter and split the document. I keep the chunk size to 1000 and the overlap to 100. This means that each chunk will be of 1000 characters and the last 100 characters of the first chunk will be the first 100 characters of the next chunk. This is for the context and known as chunk overlap. Perfect. So this is how you can use the text splitter split documents function. You need to send the document data in the form of array. Once the documents are splitted in chunks, we can get instance of vector database and store these documents into it. Firstly, let's import getVectorStore function from db.py. Now it's time to initiate a vector database and add these documents. So this is how the instance is taken from this function, and all the documents are added using addDocuments function of the instance and by passing all the documents which were splitted. Great, now this function will store the data. Next function to work on is getRelevantChunk of data. It starts with the same step, that is initiating a vector database instance. Now get and return the relevant chunk of data using similarity search function of the vector database. This function takes the user query and this gate denotes how many relevant chunk of data is required. Since our document is small, I will just keep this to 2, but you can update this based on your requirements. The documents we receive will be in array, hence we need to convert it in a single string. For that purpose, I will use the join method of Python. And finally, return the relevant chunk of data. Great, the two important functions for this tutorial of this file are done. The next function is PromptLLM. Since this tutorial is about vector database and pgvector, I'll quickly explain the logic of this function. You need these two imports for this function. Alright, so now let me walk you through the logic of this function. Firstly, this function initiates a prompt template. The prompt template has input variables as user's query and the relevant chunk of data. These is the instructions which we are giving to LLM. It says that you are a knowledgeable assistant trained to answer the question based on the specific content provided to you, and if the question cannot be answered based on the provided content, respond with I am not trained to answer this. With that, we will pass the content and the user's question. Further, we would take the Gemini's API key from the environment variables and declare the Gemini's LLM model. After that, we would chain the LLM and the prompt template. And lastly, we would invoke the chain by passing the input variables for the prompt template, which were user's query and the relevant chunk of data. Lastly, we would return the response generated by the LLM. Finally, from this main function, we will call all the functions created. First, get the document content, then to store the content in a vector database. Now I will declare a variable which will have user query. Further, I will get the relevant chunk using this query. Finally, prompting the LLM and printing the generated response. To run this project, first we will start the pgvector Docker image. Now finally we will run app.py file. There you go. So this was the tutorial on how to integrate pgvector's Docker image with LangChain project to use it as a vector database. In a way, it was a RAG tutorial, but specifically based on how to integrate the pgvector as vector database. This is how you can build RAG application, leveraging the existing LLMs to build AI-powered applications. I have documented all the code which I did in my blog. The link is in the description below. Check out to get all the code. Let me know if you have any specific questions related to RAG and I will be very happy to answer it.